So now we're going to consider the definite integral over regions that are not rectangular. So these regions are called simple regions, and they're regions that are between functions of x. So if a ranges between two numbers and y ranges between two functions of x, then the definite integral is going to be this integral. And notice that the inside limits are for the functions of x. And another simple region would be y ranging between two constants or two numbers, and x ranging between two functions of y. And in that case, the order of the integration switches, and the functions of y are on the innermost integral. So let me draw what these two simple regions look like. So here's the first region. You notice that h and g are the functions that bound the simple region. And here's the second simple region. Notice that L and K are the functions that bound, and they're functions of y, whereas in the first case, they're functions of x. Okay, so let's do an example. So if R is given by this simple region, we want to sketch the simple region and then evaluate this integral over that region. So we'll start by sketching the region. So x ranges between 0 and 2. So 0 and 2. And y ranges between 0, that's a function, and root 4 minus x squared, which looks like this. Okay, so our simple region is this quarter circle. And now we're ready to evaluate this integral as an iterated integral. So we're going to go 0 to 2 with our x, so that's our outermost integral, and then 0 to root 4 minus x squared with our y. Okay, so the antiderivative of 2y, x is just a constant here relative to y, is going to be y squared, so x still hangs out. And we're going to put in 0 and root 4 minus x squared. So we're putting in a function in our limit. It's one of our limits. And then we're putting that in for y. So we're going to get 0 to 2 x times root 4 minus x squared minus 0. We put 0 in for y squared, we get 0 squared, which is 0. And then that's going to work out to be, well, the square root's going to be taken away by the square. So we'll just be left with 4 minus x squared. And I just noticed I made a mistake here. So these are x's here. We've already integrated with respect to y. And then we'll get 4x minus x cubed, which becomes 2x squared minus x to the 4th over 4 from 0 to 2. And we put 2 in there, we'll get 8. We put 2 in here, we'll get 16. And we put 0, we'll get 0. So we get 8 minus 4, which is 4. And that's our answer. Let's do another example. Okay, so we have this region, and we want to set up iterated integrals for this definite integral, and we want to set up both. So we want to do the order of integration both ways. So we'll go x dy dx, and then x dx dy. So in this ordering, we're going to have functions of x bounding our region. So that'll go from 0 to 2/3 x, and then x is going to go from 0 to 3. That's the range of x and the range of y. And then if we're reversing this, well, we need to go from a function of x to another function of x. And if we turn our head 90 degrees, we can see that this is the lower function. It's the function that's closer to the y-axis. And if we solve this for x, we'll get 3/2 y. So 3/2 y is our lower bound, and our upper bound is 3. So once again, we're sort of envisioning this as a lower bound as a function of y and an upper bound as a function of y. And then y is going to range then from 0 to 2. So those are our two different integrals, iterated integrals, and they both should give the same answer. So if you work this out, the final answer should be the same.